Hello everybody. In this video lecture I will introduce the geology of the western part of the Harz Mountains in Germany. I will focus on the Paleozoic basement rocks and I will talk you through the stratigraphy following a geological timescale. The explanations are linked to the rock units and geological events that I pointed out in a series of field stops of a geological excursion that we have developed at the Faculty of ITC of the University of Twente in the past. Okay, let's start. This slide shows the location of the Harz Massif. It's about 320 kilometers away from the Dutch border, and it's clearly visible in dark tones because it's forested. That's why it is showing up in dark green. So that's here. This shows a topographic map of the Harz Massif. You can see that the elevation is higher than the surrounding areas, and the highest spot in the Harz is the Brocken. It's a Brocken mountain, and it's 1142 meters high. And in this map you can see the town of Goslar, an old historic mining town, the town of Bad Harzburg, and the center of the Harz, of the Western Harz, which is Klausthal-Zellerveld. This map shows, well, this is simplified, the geological map of Germany and the surrounding areas. You can see the Netherlands, northern Germany, covered by quaternary sediments mostly, and then here we find the Harz, composed of lower Carboniferous to Cambrian rocks mostly. So the Harz Massif was affected by the Variscan or Hercynian orogeny, which is a mountain building event caused by the late Paleozoic continental collision between Euramerica and Gondwana, with the formation of the supercontinent Pangaea as a result. And here you can see the position of the Harz. This is a close-up, and it shows the Variscan tectonic zones in Germany. Here you can see the Harz. This is the Rhenish Massif, and both are part of the unmetamorphic slate belt. So these rocks are practically unmetamorphic, which is different from Variscan tectonic zone more to the southeast, which has been metamorphosed, and the two terrains, they are they're bounded by a northern phyllite zone, which consists of low-grade metamorphic green schist facies rocks. And in R, the position of the Rammelsberg massive sulfide deposit is indicated. This shows a geological map of the northwestern part of the Harz Massif. That's also the area that's covered by the field trip. The field stops are shown in numbers, and in white you can see the bigger units within this terrain. So what we have here is in gray there are Carboniferous flysch deposits consisting of largely of turbidites, grey-wacky, and some shales. Some older rocks are found here from the Middle Devonian, shales and slates, and also some sandstones. This what you see here in brown is an anticlinorium of Middle Devonian rocks. Rammelsberg deposit is here. Then there are various intrusions. One here is the Brocken granite in red. Then we have the Gabbro complex in green. which consists of more mafic rocks. And then in pink we have an older raft of gneissic rocks. What you see here is a geological time scale, and on the right, going from here late Proterozoic up to Quaternary, and on the left are the geological features, rock units, or events that I'm going to discuss in this presentation. You can see that the majority of the units is from the Paleozoic, between Permian and Middle Devonian. We'll start with the oldest, which is the Iberg gneiss. Yeah, so as I already indicated, that's located here in between the granite and the Gabbro. This is a close-up. This is the granitic rock of the broken granite, and here the mafic rock of the Gabbro complex. The gneiss is outcropping in several places. It's a medium to high grade metamorphic unit. It's a crustal segment which is enclosed by the Harz, Gabbro, norite, and the broken granite, as I already explained. The metamorphism ranges from contact metamorphic to amphibolite and granulite facies conditions. It's a paragneiss, so it's consisting of palitic and siliciclastic metasediments. And the age of the deposition of the protolith is a bit controversial, but one of the lower ages of detrital zircons that have been dated are 500 to 600 million years old. So that was the Iberg gneiss. Then we go to the next unit in this lecture, which is the Wiesenbacher Black Shale, which is from the Middle Devonian, and it's outcropping here, and it contains, well, it's an important rock type because it contains the Rammelsberg mineralization. The Wiesenbacher Black Shale is a Middle Devonian calcareous black shale, enclosed in sand-banded black shale. It's structurally overlain by lower Devonian shelf sandstone in this anticlinorian, and it's the host, as I said, of the Rammelsberg ore deposit. Here, this is a nice series of maps from Andreas Müller from 2008, which is part of a great presentation of the geology of the Rammelsberg deposit. So here on the upper left is the geological map. As we have already seen, this is the location of the Rammelsberg deposit, and here we can see the paleo situation in the past. So here we have the Goslar Basin, which is an area which is relatively low, situated in a deep sea, where shales have been, marine shales were deposited. And then we have the Western Harz rise, which is an area which is more elevated. And the Rammelsberg deposit was formed on the boundary between the high and the low. This figure here, number B, is a very nice cross section, which also shows the Western Harz high, and to the left is the Goslar Basin. You can see how it is, these are Middle Devonian reefs from the Iberg limestone, have been developed and later overlain by the flysch deposits, which contained the grauwacke units. Okay, so that's the situation of the Rammelsberg deposit. Some characteristics of the ore deposit. It's a copper, zinc, lead, sulfide, barite deposit. It has been mined for more than 1,000 years, so quite a long time. It's a type locality for shale-hosted sedimentary exhalative zinc, lead, silver deposits. It has unusually high grades in zinc, lead, and silver, and a high copper gold content within the sulfide ore. The stratigraphic footwall is altered to a quartz chloride anchorite rock, and they call it a gneiss. And the mineralization in the gneiss area consists of pyrite, arsenopyrite, and sphalerite. The high-grade massive sulfide ore is there as in the form of lenses, which are composed of sphalerite, galena, and chalcopyrite, locally gold and silver rich. Furthermore, it contains pyrite, iron dolomite, quartz, manganese dolomite, and barite. Here in the upper left you can see a cross section from northwest to southeast, and it shows the position of the ore lens within the Wiesenbacher shale, which is in gray. You can see that it's a fault, but this fault has been overturned. Well, if we look at the outcrop, then we can see here that there are the sandstones, the older sandstones in the anticlinorium are exposed here. Here we can see black shales, and in close up here in B, and this is still the old shaft. So nowadays it's a UNESCO World Heritage Site, so everything here is now preserved. But the mine closed in the 80s of the previous century. And this is an example of ore, banded ore, which is rich in sulfides, like sphalerite and galena. So it's a world-class SEDEX deposit. On the left is a wire model that shows very nicely that there are two sulfide lenses were mined. Yeah, so the deposit consists of two big lenses, and in between a smaller lens of barite rich ore. And here on the right shows two models of how these SEDEX deposits can form in general. So there are vent proximal deposit and vent distal deposits. And what's important is that it's in a submarine setting with fluids flowing through faults and fractures, altering the wall rock, discharging fluids into the near the seafloor, and depending on the conditions, the sulfides are deposited proximal or more distal from the discharge sites. So if you go there, you can still see the old processing plant that was developed also in the last century from the past, from longer ago, before there were steam engines. There is a series of water wheels that generated power for hoisting the ore. And in the old shafts and adits, you can see precipitation of secondary ore minerals, which are quite beautiful. Okay, that was the ore formation event at Rammelsberg in the Middle Devonian. Now we go one step up to the Iberg limestone from the Middle to the Upper Devonian. This is an this is a reef limestone, and it's outcropping here in blue. And you can compare it, the structure, with an atoll that we can still observe nowadays. So it's built up on top of a volcano. It's quite a compact reef that was formed during the Middle Devonian, and the diameter is between 1 to 2 kilometers, and it consists of different reef facies with different types of marine organisms, including stromatoporoids, corals, um, and crinoids. This is a view from the top, and you can see that it consists of two parts. Here one to the northwest and one to the southeast, also with their different reef facies, but they're this dissected by a structure, and some people say that because of tectonic movement, one part of the reef slid off the other part, and that's why we see two parts of the reef exposed nowadays. And this deposit is now being mined. It has a very high calcium carbonate content. It has been mined since the 1930s. You can find nice fossils there. This is an example, a photograph here on the right of a goniatite fossil. Here. But this is from the post-reef building episode. This slide I've already showed before, but it shows very nicely the relationship between the Iberg limestone, which is here, and the surrounding and overlaying rocks. So later on, the reef, well, was covered by, in the late Carboniferous, by onlapping grey rocky sequences. And the relationships you can also observe in the Winterberg quarry, where the Iberg limestone is exposed. The top of the reef has been eroded partly. So there are some erosion levels, which is shown here in this drawing. Also cracks have developed, and they were filled by other materials, including fragments of other marine organisms like crinoids. Here you can see the onlapping of the younger grey rocky deposits. And one interesting feature of the top of this reef is that a seep community was found of marine organisms that flourished by using hydrocarbons that seeped out of the seafloor here. Okay, so this is the late Devonian. Which was a period that reef builders were active and built large reefs, but that was all, well, not completely, but somewhat stopped by the Kellerwasser event, which is one of the 5 big Phanerozoic mass extinctions that took place in the late Devonian. Here in this graph you can see the 5 big mass extinctions, and this is the in the Phanerozoic times. And this is the Kellerwasser event, and it's named after the type locality in the Harz Mountains in the Kellerwasser Valley, where about 60% of the genera living at the time became extinct. And the reef builders that built the Devonian reef, they were greatly affected by the Kellerwasser event. The Kellerwasser event was described here with these two horizons. So these are fine-grained shaly rocks with a lot of reduced material in it, and then the top of this second layer marks the mass extinction event. Okay, so we go up in the stratigraphy to the grey rocky sequences in the Carboniferous flysch deposits that can be found here. In Germany it's called the Klausthaler Kulm zone, This sequence of lower Carboniferous flysch deposits of thick sequences of interbedded marine shells and grey-wacky sandstones, turbidite deposits. Well, they are turbidite deposits, and they have been intruded by volcanic rock, which is called the diabase Zug, or the diabase zone. The name grey-wacky comes also from the Harz Mountains, because it was named after a grauwacke, which is a gray pudding that the miners used to eat in this area. And whenever they found rock that was barren and didn't contain mineralization, they compared it with this gray pudding, which is a grauwacke, and then later on became the English word grey-wacky. Interesting detail. Okay, so this is an example of rock in the diabase zone. So it's mafic volcanic rock extruded in a submarine environment, and you can see pillow basalts in exposed. And this is a nice photograph of columnar jointing of a basalt that can also still be observed in this rock. Then the Variscan orogeny occurred, and it's marked by crystal shortening in this northwest-southeast direction and folding in the Variscan direction, northeast-southwest. There's a nice paper by Anderson from 1997 that proposes a model of the deformation, which is mainly here related to, in this model, to subduction. And what happens here is that a plate, oceanic plate to the northwest, is diving under the area in the southeast, and in that way the Harz terrain is accreted. Well, in the last stage of this subduction process, the northwest Harz was actually starting here, and here is developing, and those rocks they have been scraped from the subducting plate. Well, that's the idea in the Carboniferous, and that explains quite well the structural fabric of this zone. You can see that this is again the northwest of the Harz. The rocks have been folded northeast, southwest. So you can see this Klausthaler Kulm zone, the grey-wacky sequences. Here you see the Iberg limestone. This is the anticlinorium with the Rammelsberg deposit here at the site, and then here you find the diabase zone with volcanic rocks, and then here to the right we have various intrusive phases with broken granite, Harzburger, Gabbro complex, and in between the gneiss. And you can also see that the plutons are post-tectonic. So that all happened in the Carboniferous. Then there are various generations of intrusions. The first in the lower Permian is this Gabbro complex. This is another map that shows more detail. It consists of different rock types, norite, Gabbro, but also the Harzburgite, and the type locality of the Harzburgite is also found in this Harzburger Gabbro. And as you remember, Harzburgite is an ultramafic rock, so with high contents of magnesium, consisting of olivine and orthopyroxene. yeah, some people interpret this complex as a layered intrusion, similar to, for instance, the Bushveld complex, which is very rich in platinum group elements, for instance, and other minerals. But not much mineralization has been found so far in this complex. It's also much smaller, and it's post-tectonic. This shows several maps of the area of the Gabbro complex and surrounding areas. So here, this is the geological map again with the Gabbro complex. This is the gneiss, this is the broken granite, and here we have parts of the diabase zone, and this in gray is the flysch sequence. The town of Bad Harzburg is here. Well, here we can see an hill shaded reduced to the pole image of the total magnetic intensity from a helicopter-borne survey from the 80s, and it shows very nicely that the Gabbro complex has a much higher relief and higher magnetic susceptibility than the surrounding rocks. So there's a lot of detail that I'm not going to explain right now, but you can, for instance, see that, well, this image suggests that the Gabbro complex continues here underneath the Kulm sequence to the west, for instance. In C, you can see a ternary image of radio element data, also from the same helicopter-borne survey, with a hill-shaded dam underneath. The Gabbro complex, and then all this mafic rock here also is very dark because it's low in radio element contents. But what you see here is the granitic rock of the Brocken, which is shown in yellow, brighter colors, and this is the ochre granite, which is another granite, which is also higher in radio elements. The gneiss here is a bit more greenish because of the relatively high thorium contents. And another thing that's very clearly visible is this structure going northeast to southwest, which dissects the Gabbro complex. It's not mapped on the geological map. In D, you can see a satellite image from the ALOS multispectral satellite, and it shows very nicely the current mining activities. This here in cyan colors is the Gabbro quarry, and this here is the diabase quarry, the Uplift quarry. Okay, let's move up. Let's move up further. The Brocken granite. Yeah, this is also Permian, lower Permian age. It's predominantly a biotite granite, so it's post-Variscan orogeny, and according to some papers, it's the result of extension and thinning of the crust and doming of the asthenosphere that generated this magma and resulted in these plutons. And the area is very scenic. This is a beautiful granite outcrop near the Wormberg. Okay. So after that, the whole area became uplifted. And if that had not occurred, then we would not have been able to have access to all these nice outcrops. So the uplift was caused by compressive stress in the foreland of the alpine orogeny. So that caused the uplift and exposed the Paleozoic basement. And this fault-bounded block was uplifted at least 2,000 meters since the late Cretaceous. So that is in two episodes the uplift took place. So one in the Cretaceous and one episode in the tertiary. And then we go to the last event that I'm describing, which is a weathering event of the granite that have been subjected to intense weathering. In various places in the Harz you can observe this interesting weathering phenomenon. It's called woolsack weathering, and it's caused by hydrolytic weathering of granite under tropical conditions near the surface in the late tertiary. And well, the characteristic is that it forms these well-rounded granite blocks, woolsacks, and in between you have this very loose weathered material, which is pale looking. There is a mechanism proposed of how this weathering takes place. What is important is that there is water penetration, so that large surface areas can be attacked. Chemical disequilibrium should be maintained for prolonged periods, and that can be caused by, or the result can be the result of rock fractures due to tectonism, opening of joints due to slope boundary conditions. So this woolsack weathering is most intense near steep topographic differences, and there need to be a steep hydraulic gradient due to increasing relief. Well, if that is the case, then rapid weathering of minerals can occur, and a loss of cohesion of the rock, and these thick grus, they call it grus profiles, are getting formed. Okay, that was the end of this video lecture. I hope you enjoyed it. Be aware, the Harz is a really beautiful and exciting place for geologists, but also for other people. But it can be cold and wet, and the weather is not always optimal. Okay, thanks for your attention. Goodbye.